So in the last video, what we were talking about was cations and anions. Cations being positively charged ions and anions being negatively charged ions. Now what we're going to do is look at what happens when we put a cation, a positively charged ion, together and we combine it with an anion to form a compound. Now this compound, what will result is what we call ionic bonding. Okay? And ionic bonding occurs when the electrons are donated. Okay? And specifically, ionic bonding is an electrostatic force. Now, electrostatic, meaning between different charges, so electrostatic, so between positive and negative, it's an electrostatic force, okay, and it occurs between metals and nonmetals. And we've actually already looked at metals and nonmetals. But let's re-look at this and re-look at these two distinct definitions of ionic bonding. First, that electrons are donated, and second of all, that it occurs between metals and nonmetals. Okay, so let's use an example to help us understand it. Let's use magnesium oxide. Now, what we're going to do right now is we're going to draw the Lewis dot structure of magnesium. If you want to challenge yourself, you can pause this video and draw it yourself. If you want a little bit of help, I'll help you with it. You should be looking at your periodic table and seeing that magnesium has 2 valence electrons. So with my Lewis dot diagram, I'm going to draw magnesium with 2 dots. 1, 2. Okay? And then oxygen, if you look at the periodic table, has 6. 1, 2, 3, 4, 5, 6 dots. Now, the ionic bonding that occurs, and remember, ionic bonding meaning that electrons are going to be donated, okay, occurs because magnesium wants to get rid of these 2 excess valence electrons. It would rather have 0 valence electrons in its outermost energy level and give those 2 valence electrons to oxygen. So what it's going to do, it's going to give 1 to oxygen there, and it's going to give the other one right here. Now, magnesium has no valence electrons in its outermost energy level, and oxygen now has 8. So, let's look at this really quickly. Let's make sure our 2 definitions work. Electrons are donated. That's our first definition of ionic bonding. Okay, and yeah, that's true. Magnesium donated 2 of its valence electrons, its 2 valence electrons, to oxygen. Okay, and this occurred between a metal, which is magnesium, and a non-metal, oxygen. If you'll notice, all of these, anytime you have ionic bonding, it's always going to occur between a metal and a non-metal. So let's look at another example. Okay, we've got calcium chloride. Now we've got 2 chlorides, so if we write it out properly, we've got calcium, and calcium has 2 valence electrons. And we've got chloride. And chloride, Cl, we've got 2 different chlorides, so I'm going to draw 2 chlorides right there. And chloride has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now I'm going to get out my blue pen and I'm going to show you calcium, which is my metal, donating its electrons. Well, it's going to donate this 1 valence electron to this 1 chloride. So this chloride now has 8 valence electrons. And it's going to donate this valence electron to this chloride. So that chloride now has 8 valence electrons. So it's now happy. Okay? So this is what ionic bonding is. Literally, your metal is going to be donating a valence electron to a non-metal. Okay? And so, yeah, they look a little bit different, but you still have that donation. Okay? So let's talk really quickly about some characteristics of ionic solids. Okay? If you notice really quickly, the way that ionic solids are organized, let's say you've got lithium chloride, so you've got Li plus and Cl minus. Well, that lithium is going to be surrounded by 6 other chlorides. Okay, so there's going to be a chloride here, a chloride here, a chloride behind it, a chloride right here, a chloride on the other side. It's like a cube with lithium in the center. Okay, so as a result of this really nice, and this is actually called a crystal, okay, ionic solids create crystals. It's a very organized, very well structured solid. Okay? Ionic solids, as a result of this crystalline structure, okay, there is a large attraction between their ions. So, first of all, there's a large attraction, whether it's between magnesium oxide or calcium chloride and chloride, it doesn't matter. There's a really strong attraction or a large attraction as a result of this crystal structure, and we can look at it more in class. But as a result of this large attraction, okay, ionic solids have a very high melting point. Okay. Another thing about ionic solids is that when they are dissolved, and only when they're dissolved, then they can conduct electricity. Okay. Once you guys have this written down, pause it, work on the practice problem, and what the practice requires is that you guys do exactly what we did up in the example problem. Okay, so do the practice. Okay, and then we'll continue on talking about ionic bonds down below. So pause this video. Alright, ionic bonds, well, this is just going to be a review. Ionic bonds are made up of metals and nonmetals. And most importantly, they donate their electrons. We'll look later on when that's not the case and we get a totally different type of bonding. But with ionic bonding, they're donating their electrons. Okay? Let's look right now at naming ionic compounds, since we just named, in the last section, we just named cations and anions. Let's name ionic compounds. Now, it's not too tricky. All you have to do is write the cation name, followed by the anion name. Okay, so let's look at an example. We've got CaO for our first example. Well, as you remember from our practice, Ca is just our calcium ion. Okay, so we're just going to write, instead of ion, we're just going to write calcium. The only tricky part of this is when we're naming oxygen. Now, O, it's not oxygen, neutral oxygen. Okay? Instead, it's the oxygen ion, and we'll look at that in a little bit, why it's the oxygen ion and not just oxygen. So instead of writing calcium oxygen, we would write calcium and write the name of the anion, so it's going to be calcium oxide. So the name of CaO is calcium oxide. Let's look at another example. NaOH. Well, if you remember, OH is one of your polyatomic ions. Okay, so what you're going to do, you're going to start off, write the name of the cation, so sodium, and then write the name of your anion. Well, the name of my anion is hydroxide. Sodium hydroxide, and I'm done. So it's actually pretty nice and easy, guys. You just have to write the name of your cation and then the name of your anion, and you're done. Okay? So pause and work on this practice right now. Okay? Alright, last thing, we're going to be writing the formulas for ionic compounds. Now, the interesting thing about ionic compounds, guys, when we add up the charges of your ionic compounds, they add up to 0. So I've got a trick for you, as always. It's called the crisscross method. It's not the crisscross swoosh method, it's just the crisscross method. So what you're going to do is the following. Okay, you've got sodium and chloride, and we need to write it as an ionic compound. So I'm going to write sodium with its charge, so Na plus 1, okay, and then chloride with its charge, Cl minus 1. Then I'm going to crisscross, meaning I'm going to take the charge in, that's the exponent for sodium, and I'm going to put it down as the exponent for chloride. I'm going to take the exponent of chloride and make it the subscript for sodium. Okay, so now this becomes Na1Cl1. And if you notice, Na, which has a +1 charge, Cl with a -1 charge, there's one of each, they cancel each other out, and all your charges add up to 0, which is really nice. Now, you've never seen Na1Cl1 because, well, you can simplify it, guys. It can just be NaCl. Okay, let's look at a little bit of a more tricky one. Sodium and sulfur. Hardest part, guys, is finding the charge. So we've got Na, which has a +1 charge, and sulfur, which has a 2- charge. Okay, so you got sodium and sulfur. Now, crisscross your charges. Okay, so that 2 is going to become a subscript for sodium. That 1 is going to become a subscript for sulfur. So it becomes Na2S. Now, let's double check to make sure that my charges really do add up to 0. Na has a +1 charge, so multiply that by 2. Sodium is now contributing a +2 charge altogether. Sulfur has a 2- charge, so +2 -2, total of 0. So notice this crisscross method works very nicely. Okay, so what I want you guys to do right now is turn and work just on these first two. Work on magnesium and chlorine and aluminum and oxygen, and then you're done with your homework. Okay, I don't want you to have to finish it, so just do magnesium and chlorine and aluminum and oxygen.